So we have a circuit with 4 resistors. I'd like to find the current and the potential difference for each resistor. Please keep in mind potential difference just means the voltage drop. Same thing. So we want to find I and delta V for each of these resistors. Now as we follow a path, we have to pass through the 100 ohm resistor, but then we have a choice. We have a choice to come down this middle branch or through the right-hand branch. That means this middle branch is in parallel with this right-hand branch. If we go through the middle branch, we have to pass through both the 200 and the 400 ohm resistor. That means they're in series. Series means they are connected one after the other. You do not have a choice but to pass through both. So what we need to do is we need to simplify this down until we have enough information to solve it. So what I'm going to do first is combine that 200 and 400 in series. Now I know that the 100 up there is in series with this whole combination, but you have to find the whole combination before you can actually add them together. So 200 and 400 in series, we simply add them together. So 200 plus 400 is 600 ohms. So those two together in series are equivalent to having one resistor with a value of 600 ohms. The next step we have to take is to combine these two in parallel. We know they're in parallel because as we follow a path from the battery, there's a branch, and we have a choice. We can pass through either the 600 or the 300 to make our way back to the end of the battery. That puts them in parallel. So we still have the 100 there. 1 over R equivalent would be our 1 over 600 plus our 1 over 300. So, nice round numbers, I like that. So R equivalent would be 600 over 3, so 200. Oops. Questions on coming up with the equivalent resistance? So similar to when we have this 1 over relationship, our overall equivalent resistance is always going to be smaller than the ones that we're looking at. 200 is smaller than both 600 and 300. Let's take this one step further. Those two resistors, the 100 and 200, are now in series. If I follow a path around from the battery, I have to pass through both. In series, they simply add together. So 300 ohms is our total overall equivalent resistance. Easy enough. Well, we know the battery voltage is 20 volts. This is our equivalent resistance. So the current is going to be the EMF over the equivalent resistance. So 20 volts over 300 ohms. It's going to be what, 0.067 amps. And I always have to check myself because I don't trust myself. So this battery, that's the total current. That's the total current the battery forces to flow. The amount of current that flows depends upon the battery voltage and overall how much resistance you have. So we know that this resistor, the 100 ohm resistor, has 0.067 amps of current flowing through it. But when that current reaches this junction, it's going to split. So these two branches are not going to have the total 0.067 amps that flow through it. They'll have a portion. But we can figure it out very easily. If we take one step backwards, this overall equivalent circuit was making up for these two in series. So we know this one has 0.067 amps of current. This one has 0.067 amps of current. Got that? So delta V, the potential difference across these two, will be just the current times the resistance. We know delta V for a resistor is I times R. So this will be 0.6, no, sorry.
6.7.
Yes. 6.7 volts. Delta V for this one will be 13.3 volts. Okay there? This 100 ohm resistor is the original 100 ohm resistor. So we're done with that one. We don't need to worry about this guy anymore. We have his current and his potential difference, his voltage drop. We need to work back though to find it for these other three resistors. That 200 ohm resistor was equivalent. It represented the 600 and the 300 in series, parallel. So now that we know the information for the 200, what do we know about the 600 and the 300?
They both have the same voltage.
They have the same voltage. If there's 13.3 volts across this equivalent, that means I have to have 13.3 volts whether I come through this branch or through that branch. So both of them have to have the 13.3 volts across them. Current, just using our equation again, current will be delta V over R. So 13.3 divided by 600. This one has 0.022 amps. 13.3 divided by 300. 0.044 amps. Together they add up to 0.066. Now technically they should add to 0.067, but we've been rounding our numbers. So they can be slightly off and that's okay. So that 300 ohm resistor is this one. So we're done with this guy. We know its voltage drop, its potential difference, and its current. Two more. That 600 ohm resistor was equivalent, it represented these two, the 200 and 400 in series. We know that 0.022 amps of current flows through this middle branch, and we know there's a drop of 13.3 volts across that middle branch. So what can you tell me about these guys?
The current through them is 0.022.
Right. Both of them have the current of 0.022 amps. Now, voltage drop, current times resistance. This is going to be, what, 4.4 volts, and this one will be 8.8 volts. So simply I times R gives us the voltage. Questions on any of that? Be very easy to find the power generated in each of them now. Power is simply I squared R. We know their currents, we know their resistances. Easy to find power. If we wanted to know total power in the circuit, we would just use the total current and the equivalent resistance. We'd have the total power generated.